In this example, we're looking at the equation y is equal to x squared minus 2x. We're going to find the area between that function and the x-axis, and this time our limits of our interval are from -1 to 1. Okay. So again, we always start with the question, where is this function in relation to the x-axis? So is this above or below? So we're going to go ahead, find out what x is equal to at the endpoints of the interval, and that'll help to inform us where exactly this function is in relation to the x-axis. So when x is equal to -1, y is equal to -1 squared minus 2 times -1. So that becomes 1 plus 2 is 3. So it's above the x-axis. And then when I take x is equal to 1, I get that y is equal to 1 squared minus 2 times 1, which is 1 minus 2, which is -1. Okay. Notice on one side I'm above the x-axis and on the other side I'm below. So what this tells me is that my function crosses the x-axis. The question is, where does that happen? Well, that happens where y is equal to 0. In other words, it happens at an x-intercept. So what I have to do is I need to take my function here, set y is equal to 0, and that's going to equal x squared minus 2x. And now I need to go ahead and solve for x. So when I do that, I can factor an x out, and I get x times x minus 2. So that means that my x values are 0 and 2. Okay, so those are the places where my function crosses the x-axis, right? Well, notice something here, that 2 is not... This is not in my -1 less than or equal to x less than or equal to 1. 2 is not part of the interval that I'm looking at. So well, the one part where it is within that interval is when x is equal to 0. So what that tells me is that I am above the x-axis. Okay. When I go from -1 to 0, I'll put like a little arrow there. That's it. -1 to 0. And I am below the x-axis when I go from 0 until I hit 1. So what that means is that I can't just do one definite integral in order to find my area, okay? For the first half, where I'm above the x-axis, I just take the definite integral of x squared minus 2x. But in the second half of that interval, between 0 and 1, I have to take the negative of x squared minus 2x in order to find the area. So here's what we're going to do is that our area is going to equal, so where I'm above the x-axis goes from -1 to 0 of my function x squared minus 2x dx, okay? And then what I'm going to do for where I'm below the x-axis, I'm going to do like I did in the previous example, okay? I'm going to take the negative and I am going to reverse my, what I'm going to do is I'm going to change this to a plus, and I'm going to reverse my my limits of integration. So the integral from 1 to 0 of x squared minus 2x dx, like that. Okay, so remember that what this does when I take plus the integral from 0 to 1, okay, remember because I'm below the x-axis, for that, I'm already taking a negative, so I've got one negative there. And then when I flip over my limits of integration, that creates another negative. So the negative times the negative is what gives me the positive here. Okay, so in this case, okay, I'm going to go ahead. I'm going to take the antiderivative. Now, the good thing is that I'm taking the antiderivative of the same thing here, right? So I've got x, for the antiderivative of x squared, I have x to the 2 plus 1 over 2 plus 1 minus 2 times x to the 1 plus 1 over 1 plus 1. And that is evaluated here between -1 and 0. Okay, and then I'm adding to that the same antiderivative. So x to the 2 plus 1 over 2 plus 1 minus 2 times x to the 1 plus 1 over 1 plus 1. And this one's going to be evaluated from 1 to 0. Okay, so really quickly I can simplify the 1 plus 1, cancel that out with the 2 in both of those. Okay, so my first area is going to be 1/3 x cubed minus x squared. Okay. And that's going to be evaluated from -1 to 0. And then again, I'm going to take 1/3 x cubed minus x squared, and I'm going to evaluate that one from 1 to 0. Okay, so I'm going to go ahead and now figure out for my three x values, -1, 0, and 1, what these values are going to take on. So when x is equal to -1, I have 1/3 times -1 cubed minus -1 squared. Okay, so when I do that, I get -1/3 minus 1. So -1/3 minus 1, that equals -4/3. Okay, when x is equal to 0, all right, I have I've got 1/3 times 0 cubed minus 0 squared, and that's just equal to 0. And then when x is equal to 1, I have 1/3 times 1 cubed minus 1 squared, and that is going to equal to 1/3 minus 1, which will equal to -2/3. Okay. All right, so now taking those three values, putting them into my equation here. Okay, so my limit's going from 0 to -1, so I put 0 in first, minus the value at -1 is -4/3. Okay. Oops. Okay. So that is that is going to give me the area of the first piece. And I'm going to add to that the area of my second piece. So the on top again is 0. So that value is 0. The value at 1 minus -2/3. Okay. So what happens is I have a +4/3 plus a +2/3. That is 6/3, which simplifies down to 2. So the area, okay, between my function and the x-axis, okay, between -1 and 1 is going to be equal to 2.